Hi. In this video, we're going to look at a third example of solving problems using impulse and the change in momentum. So I've already gone ahead and written out the full expression of the relationship between impulse and the change in momentum. On the left side here, I have impulse and force and time. And then on the right side over here, I have change in momentum. And there's different ways you can write that. So that's what this really long equation basically says. All of these quantities are equal to each other. So let's get started with the problem. A 44.2 kilogram skateboarder using his lucky skateboard cruises down the sidewalk at a speed of 6.50 meters per second when the back wheels fall off. The skateboard starts dragging it against the ground, and the friction brings the skateboard to rest in 4.30 seconds. What is the average force exerted on the skateboard? So I'm going to begin by drawing a picture of before and after. And that always helps to visualize the situation. So if you're working this out with me, I would encourage you to put your artistic skills to the test here. Okay, so we've got a skateboarder. He is moving at a speed of 6.50 meters per second. His mass is 44.2 kilograms. And then after he comes to rest. So the skateboard is broken. All that's left is the front wheels, and he is sad. Okay, and he's no longer moving anymore. So 0 meters per second. All right, so I've got my picture drawn here. Now I'm ready to start solving the question and ask for the average force exerted on the skateboard. So we're going to be looking for this quantity here. Okay. Let's go ahead and write down what we know. We know the mass of the skateboarder is 44.2. We have an initial velocity here of 6.50, and that's in the positive direction in this case, to the right. And I chose it to be positive because I like positive numbers. The final velocity is 0. We see that over here. And looking back at the question, the word problem, it says that it comes to rest in 4.30 seconds. So I know that that's a time, seconds. So time is 4.30 seconds. Okay, so now we go about solving for the force. That's what we need. So to solve for the force in these kinds of situations, we're definitely going to be using the only quantity that has force in it. So I'm going to choose that over here, force times time. And I'm going to set that equal to something else. And I need to choose what I should set it equal to based on the other information I have. I could set it equal to the delta P, but I would have to just work out what delta P means, and I would eventually just get to this one right here. This is the quantity I'm going to set it equal to, just because of convenience. I've already written it out. I know that this is the change in momentum, the mass times final velocity minus the mass times the initial velocity. And this is something that you may just know already just by knowing change in momentum. Okay, that just means, mvf minus mvi. But this is a fine way to construct our equation because all of these quantities are equal to each other, and we pick the ones that we need. So let's go ahead and start solving then. We can keep the force as F. The time is 4.30 seconds. The mass is 44.2. Oh, but the final velocity is just 0, so this whole term will just go away. Then we have the initial momentum over here, and the initial speed was 6.50 meters per second. All right, so now we start doing some work. This just goes away. This is going to stay the same over here for now. So we'll have 0 from this minus, and then we have 44.2 times 6.50, and we have 287.3. Looks like all of our measurements have 3 significant figures, so we're going to round that just to have 3 as well. 287 kilograms times meters per second. It's 0 minus 287, so that'll just leave us with negative 287. I'm just going to get rid of the 0 then. So I have negative 287. Now I'm going to solve for force by dividing by 4.30 seconds on both sides. And so my force is, calculator, 287 divided by 4.30, 66.7 newtons. I know it's newtons because it's force, but just to be really clear about it, we have kilograms times meters per second divided by seconds. So that would give us units of kilograms times meters per second squared, because we're dividing by seconds twice because of this one down here. So this is a mass times acceleration, and mass times acceleration is force, F equals ma. So this is newtons for the force. 66.7 newtons. Did you catch my mistake? It was negative 287 divided by 4.3, so this should be a negative force here. It's a frictional force acting against the motion, so it slows them down. So negative 66.7 newtons. So that's all I've got for you in this video. Remember, a bad attitude is like a flat tire. You won't get anywhere until you change it.